You think you control the elevator? Think again. You look at a 100-story skyscraper and see nothing but a shiny monument of glass and steel. But you are only looking at the polished surface. Down in the mechanical bedrock, it is a different story. This structure is not just a building. It is a vertically stacked, fully autonomous city. And like any profitable mine, the real treasure is hidden deep within the operational mechanics. Take the elevators. They don't just go up and down when you push a button. They use destination dispatch algorithms, grouping passengers to eliminate bottlenecks. It's pure transit optimization. But foot traffic is just the topsoil of this operation. Let us dig deeper into the plumbing vein. Pumping heavy water 1,000 feet straight up into the sky requires massive, continuous mechanical force. If you just pushed it from the bottom, the pressure would be catastrophic. The pipes on the lower floors would literally explode from the sheer weight of water. So engineers build hidden pressure-reducing valves every 20 floors, creating isolated pressure zones. It's a cascading waterfall, carefully controlled in reverse so your office sink doesn't detonate. Now think about the indoor climate. A sealed glass tower is essentially a giant, sun-baked greenhouse. Add the body heat of 10,000 workers and thousands of glowing computer screens. The building isn't fighting the cold outside, it's desperately trying not to melt inside. That requires immense industrial HVAC lungs, hidden away on mid-air mechanical floors that you never see. These dark floors are the respiratory system, cycling millions of cubic feet of air. They also house electrical substations, stepping down high-voltage city power for everyday office use. Without these hidden power nodes, the voltage drop over 100 floors would cripple operations. You're sitting inside a massive machine, completely oblivious to the gears turning around you. But the absolute biggest threat to this vertical city is not water pressure or trapped internal heat. It is the invisible, relentless force hitting the exterior glass every single day: high-altitude wind. At 1,000 feet up, wind currents hit the glass with the force of a hurricane. You might think the goal is to make the building perfectly rigid and unmoving. That is fool's gold. A perfectly rigid tower would simply snap right in half under extreme pressure. The secret is that the skyscraper is actually designed to sway in the wind. But to keep you from getting seasick at your desk, they use a hidden counterweight. Deep in the crown lies a tuned mass damper, a suspended multi-ton steel sphere. When the wind pushes the building east, hydraulic shocks push this massive pendulum west. It absorbs the kinetic energy, canceling out the sway before you even feel it. It's a structural shock absorber, fighting the sky's momentum with pure, calculated gravity. Even the waste management relies on gravity, using velocity-controlled drops so trash doesn't become a projectile. Every single system is a carefully balanced physical equation, hiding right behind the painted office drywall. You walk past these humming mechanical veins every single day, completely blind to the engineering miracles inside. The real genius isn't the height of the tower, it's the invisible logistics keeping it alive. The next time you look at a city skyline, do not just look at the shiny glass. Count the floors. Look for the dark, windowless bands wrapping around the middle. Those are the mechanical floors, the hidden engine rooms of the vertical city. Once you know where to dig, the whole world looks like a blueprint. What is the most mind-blowing hidden mechanic you learned about today? Let me know in the comments below.